I like to say that during exploration, science is our toolbox for survival.
Jacob Bleacher, Chief Exploration Scientist for NASA. Welcome to About Space Today's special report. I'm David Denault. Unlike any previous NASA missions, Artemis II has focused on how man will survive in the harsh environments of space. Artemis II isn't about going around the moon, it's much more. The Artemis II mission has been a groundbreaking journey that took 4 astronauts farther into space than any human has ever traveled before, an incredible 252,600 miles from Earth. Artemis II has performed a free return trajectory, allowing the crew to test the Orion spacecraft systems. NASA's Chief Exploration Scientist Jacob Bleacher says that science will be our toolbox for survival.
Artemis II is a test flight. It truly is exploration. There will be a number of firsts that we'll be proving out on this flight. And I like to say that during exploration, science is our toolbox for survival. With that in mind, I'm excited to present to you our Artemis II integrated research campaign, which involves activities across biology, human research, space weather research, and also some planetary geology. Our integrated campaign is designed to help unlock more time for science on future missions by minimizing crew time spent on other activities and increasing crew and support team efficiency on the science tasks themselves, all while learning how to best thrive in the deep space environment. During this flight, we will learn how the spacecraft behaves. Through our research campaign, we will also learn how we, human beings, behave in that same environment. The combination of these two things will help us optimize our time in future missions. We'll be flying a payload called Avatar, which stands for a Virtual Astronaut Tissue Analog Response. Basically, Avatar enables us to mimic individual astronaut organs, and Artemis II will mark the first time that these types of devices have been tested outside the Van Allen belts or away from the ISS. We will test if we can use these astronaut avatars as tools for measuring and predicting our human response to the deep space stressors. To evaluate this, scientists will compare Avatar data with space station findings we've already collected, as well as with samples taken from our crew both before and after the flight. For NASA, Avatar could help inform measures to ensure crew health on future deep space missions, including personalizing medical kits for each astronaut. For citizens here on Earth, it could lead to advancements in individualized treatments for diseases such as cancer. We'll also be flying an activity called Archer, Artemis Research for Crew Health and Readiness. For the Archer study, crew members will wear movement and sleep monitors called actigraphy devices before, during, and after the mission. These wristband monitors will enable us to study real-time health and behavioral information for the crew members and help scientists study how crew members' sleep and activity patterns are affected and how overall health and performance is affected. The study will evaluate how our crew members perform individually, as a team throughout the mission, including how easily they can move around within the confined space of their capsule. We'll also measure a set of immune biomarkers. For the immune biomarker study, crew members will supply saliva samples through the flight, and they have done so on Earth and will do so when they return for comparison. Scientists will gain insights into how the astronauts' immune systems are affected by the increased stressors of the radiation environment, isolation, and distance away from Earth during deep space flights. We'll also extend a set of ISS activities to the Moon called Spaceflight Standard Measures. Astronauts will collect a set of measurements spanning multiple physiological systems to provide a comprehensive snapshot of how spaceflight affects the human body. We will conduct also physiological assessments, including testing their head, eye, and body movements before, during, and after the spaceflight, and that will be compared with blood samples that are taken before and after the flight as well. As soon as possible after landing, the crew members participate in basically an obstacle course to see how quickly they can function soon after going through a gravity transition. A few days later, they'll conduct a simulated spacewalk, and we'll do various tasks in a pressurized spacesuit again to investigate how quickly, again, they can adapt to that change in gravity. That prepares us for landing on the moon and eventually down the road going to destinations such as Mars. During the flight, we will make measurements with a suite of radiation sensors. You may remember that we've did something similar during Artemis I. Crew members will keep detectors in their pockets of their suits so that we can measure their individual exposure in real time during the flight. 2 other sets of sensors will also be placed in Orion. One will monitor radiation at different shielding locations in the spacecraft so that we can gain a better understanding of what the radiation protection does for our crew members on board. We will also be partnering with the Germany Aerospace Agency, or DLR, to provide sensors similar to what they provided during Artemis I. And the crew will deploy these around the Orion, again, to give us a comprehensive view of that radiation environment. Last but not least, a very exciting aspect to it is the ability to observe the moon. So you've heard a little bit about that already. And if we could cue up our first image here. Our crew will take time to observe the moon as they pass around the far side of the moon. Far side is the side of the moon that we never see from here on Earth. The moon will look about like holding a basketball at arm's length to them from the Orion. And if we could cue up the second image as well now, just to give another look here. Depending on when the mission launches and the final flight path, it's possible they'll see parts of the moon that have never been viewed by human eyes. All of the Apollo missions launched for the landing to occur in the early lunar morning. A lunar day includes 14 days of sunlight, 14 days of darkness. So basically, the crew that were flying around the moon all saw the same lighting conditions. So this could be a very unique opportunity to see the moon. We'll be asking them to look for things like albedo differences, variations in the grayscale that human eyes really can detect. In addition to their observations, which they'll be communicating back to the Earth, our science support teams will conduct their own test flight of a sort here on the ground, testing out how our support teams work to make sure that we can best support them when they actually go land on the moon during Artemis III and beyond. One last piece to our Artemis II science activities includes the deployment of 4 international CubeSats. Could we go ahead and cue up that image? Artemis II mission has provided us with the opportunity to deploy 4 CubeSats. Those are basically shoebox-sized payloads that essentially act as their own spacecraft once we deploy them. Our partners in Argentina, Germany, Korea, and Saudi Arabia are all partnering with NASA to take advantage of the opportunity that we have with Artemis to fly their own CubeSats. Each has its own objectives, but in general, all of the CubeSats are conducting complementary space weather measurements to the types of research that NASA's doing. So we're excited to provide this opportunity to our partners as we lead the way in space exploration and exploration of the moon. So real quick to conclude here, our integrated research campaign for Artemis II builds upon what we learned in Artemis I, and it sets the stage for successful exploration of the moon and ultimately onto Mars. Our campaign will help us understand the space weather that we'll face during future lunar missions, how to observe the moon and communicate with the support teams here on Earth, and in general, how we will react to, survive, and thrive in that deep space environment. Therefore, I like to say that Artemis II science is the science of us. Artemis II science is the science of humankind and how we'll act as we continue to press the boundaries and explore in deep space. Thank you very much.
The Artemis II crew is scheduled to splash down in the Pacific Ocean off the coast of San Diego, California, on Friday, April the 10th at approximately 5:07 p.m. Pacific Daylight Time or 8:07 p.m. Eastern Daylight Time. You can see all of our reports on our Facebook page at aboutspace.today or on your favorite platform. And if you like our reports, be sure to click like, follow, and hit that subscribe button. And to all our listeners around the globe and here in the U.S., thanks for taking your time from your home or from where you work to listen today. I'm David Denault.